Hey guys, Mysis here, and I'm going to be doing the problems that I didn't get a chance to do in class. This is for my 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 statistics course, Math 1600 at Stanislaus State. I'm going to be doing numbers 4, 5, 6, and 7 on the review for the midterm for midterm number 2. So I'm going to run through these real quick. For the other ones, you'll just have to look on Blackboard for the solutions to those. Okay. All right, so number 4, hold on, I'll be right back. Give me 1 second here. Okay, so here's the problem for number 4. I'm going to run through the solutions for these, and you're gonna have to read the problems yourself. I fully believe that you guys can read. So let me go ahead and work this out here for you. So this is a normal distribution problem. So I'm going to just go ahead and draw my normal model, let you see what's going on here. Here's my mean of 30. So I'm going to write these down here. I have got a mean of 30 and a standard deviation of 5 minutes. Let's write them, make sure I have my units in here. And I want to know the probability. I want to know the probability that there's 35. I want to know this area right here. The probability that the student gets to the college more than 35 minutes than their normal travel time. So I'm going to need to find a z-score. So z equals 35 minus 30 over 5. Okay, recall that the formula for z-score was x minus mu over sigma. All right, so we get 5 over 5, which is 1. And so I'm looking for the probability that z is greater than 1. So I'm going to go ahead and use my z chart again and looking for the area. A lot of times the z chart will only show you the areas under. So you'll need to do 1 minus for the z chart. Z is less than 1. Remember, you're only doing this because the z chart only shows you less than area. You're not going to do it all the time. You're just doing it because it shows you less than area. So you got to do the opposite of what's going on there because otherwise you won't get the right probability. And that's why I show you this probability shaded up like that. Okay. So what is this? This is going to end up being 0.1587. Or if you want, you could put your answer as 15.87%. All right. Either way, I'll accept either one. Okay. So let's go ahead and do the next one. All right, so on this one here, I want you to see that the probability that she makes it, which is the probability of success, is 0.3, okay, it's right here, 0.300. The probability of failure, oops, not 1 minus p, which I call q, is 0.70. So that's the probability she does not get a hit. So what is the probability that she hits 7 out of the 10 bats? That is a binomial probability. All right, so we're looking at the probability of 7 out of 10. Now, how do I know it's binomial and not geometric? Because I have an n here. I have a certain number of bats that I'm going to get out of. 7 out. It's not the first success. It's 7 successes out of 10. So I'm going to write this 10, choose 7. That's a combination, times 0.7 cubed times 0. I keep wanting to put that point there. Sorry, guys. 0.3 to the 7th power. Remember, in your calculator, this is probably going to be something like NCR. So that's what I entered in my calculator, and I'm going to get 0.009. If you see me glancing over to the side here, that's because I have my solutions written out to make sure I got them right, okay? I'll accept decimals for your probabilities. So how many hits do we expect her to hit out of 10 bats? So this is a mean problem. The mean, or the expected value, is NP. For a binomial distribution. So that's going to be 0.300 times 10 at bats, and we expect her to have 3 hits, right? All right, let's go to the next one. What's the probability that a randomly selected calf was born in the night or was female? So here are the female right here. So this is this total here. So it could be female, which is 252, or all of the calves that were born at night, 233. However, if you notice here, I did these three to get this total, and then these two to get this total, which means I overlapped 116. So I need to subtract out 116, and then that's divided by the total 513. So I'm going to get 369 over 513, which is going to give me 0.7193. And I'd like to have you write them out in 4 decimal places here, just to make sure that we get, you know, somewhat similar results when I'm grading these out, okay? All right, let's go on to the next one. Number 7. Now for this one, I think what we're going to want to do is we're going to want to add up and sum these parts of the chart here. So if we add eaten with no level of parasitic infection, lightly and highly, and we add up those together, that's going to give me what the probability that the fish was eaten. All right, so it's going to be 0.007 plus 0.071 plus 0.263, which gives me a probability of 0.341. If you want, you can write that right here. All right, so we know that this entire table must be equal to 1. So we're going to end up with, right here, we have to subtract 1, and we're going to end up with this little piece here, 0.659. And that's going to help me out in just a second, okay? That's why I did it, because it's going to help me out. All right, oops, I need to scroll up a little bit here. Okay, so what is the probability the fish was not eaten and was not infected? So not infected, not eaten, I'm looking for this question mark right there, right? So in order to find that question mark, this box, and this box have to all equal to 0.659. So what I could do is 0.659 minus 0.319, because I want those added together. And that's going to give me the probability 0.276. All right, that's my answer. Okay, so the last one here. If the fish was highly infected, what's the probability it was eaten? So this is a conditional probability problem. Well, got a little too close there. This is a conditional probability problem. So it's the probability that the fish was eaten given that it was highly infected. Now, using the formula for that, I'm going to scroll up. I'm going to scroll up here for a second because I know we'll be losing that. Well, you know what I'll do? I'll try it. There we go. Zoom out a little bit. Okay. So given it was infected, so we're going to use the formula here. It's going to be P, that it was eaten and highly infected, divided by the probability that it was just highly infected. All right. So now we're going to have to plug in that. So that's going to be, now the probability that it was highly infected is the sum of these two right here. Okay, I just want to make sure you know where I got this next number coming up. Okay, 0.263 over 0.327. Now remember, I got 327 from adding these two highly affected numbers up there. Erase that right there. So that's going to give me an answer of 0.8043, or if you want, 80.43%. Now I don't know if you can see that because my face might be in the way. Oops, my face might be in the way. Sometimes the sometimes the screen, the little box that has my face in it, is in the way of that. So I'm going to move here. Here's number 8. If you wanted to look at number 8, I have the solutions down already for that. All right, so those are some solutions for the problems, similar problems that will be on the test, and I don't really see them being too much different than what I have here already. And what I'll do is I'll post these solutions up on Blackboard so you can see all the rest of them, and I'm just kind of scrolling through them so you can pause it and see all of them here too, okay? All right, catch you guys later. Good luck on your test this week. Bye.